Alrighty, hello chemistry students. Today we're going to start talking about binary compounds and how different elements get their charges and how charges can change when we bond different things together. So we've already learned about bonding. We know that there's different types of bonds. So now we're going to talk about how that bonding can happen based on the charge of a compound. So just to revisit some notes, remember that an ion is a charged particle. Okay, last unit, or if you're in honors chem, we also talked about it this unit, we learned how that there's a trend of valence electrons, that as we go from column to column, each column has a different number of valence electrons. And remember, we skipped that transition elements in the middle. So the first column has 1 valence electron, the second has 2, we skip the middle, the third has 3, 4, 5, 6, 7, 8, and so on. Okay? So we also talked about how things can form cations and anions. Remember that a cation has a positively charged, it's a positively charged ion, whereas an anion is a negatively charged ion. We talked about how generally things over here, like for instance sodium, actually sodium is right here, that one above is lithium. Sodium has 1 valence electron, and we learned how sodium wants to give that 1 electron away to get its full outer shell. And if it gives its outer electron away, it's going to have a +1 charge. Okay, if we look at beryllium, Be, located here, it has how many valence electrons? 2. And if we give those 2 away, it's going to result in a +2 charge. Okay, and that's the same as we move forward. This one will be a +3 charge. Okay, this is plus or minus 4, and we'll talk about why that is. So let's think about fluorine over here. Remember, fluorine has 7 valence electrons. So is it going to be easier for fluorine to gain 1 more or just lose 7? Of course it's going to gain 1 more, so if it's getting extra negativity, it's going to become a negative anion, which we've already learned about, to give us a -1 charge. -2 comes here, and -3 comes here. And when I say these, everything in this column has a -3 charge. Everything here has a -2 charge, and everything in that 7th column has a -1 charge. And then, of course, our noble gases have a charge of 0 because they're not counted. They have no charge. Okay, so remember that going forward, because that's going to be really helpful information when you're deciding how to write formulas and how things are going to bond together. So, a definition for you. Binary compound. A binary compound is a compound formed from 2 different elements. Okay, there may or may not be more than one of each element. So a binary compound is 2 different things. So H2O, NaCl. Okay, so 2 different elements together. In general chemistry, we're only going to focus on binary compounds and naming binary compounds. In honors chemistry, we might go a little bit beyond that, but for the most part, we're going to be focusing on binary compounds. This whole unit is going to focus on how to name these things. What are they called? Okay. So our next thing we're going to look at is how to write things when they have a charge. I think I don't have a slide for this one. So I'm just going to go up to the whiteboard and kind of walk you through some things. In your notes it says, when writing formulas for compounds, the charge of each element must be taken into account. So we're going to look at the charges of things when we're making bonds and things are forming together. And it gives you some steps. So we're going to form a bond between Na and Cl first. So let me go back to the whiteboard. Alrighty, so like the example says, we're forming a bond between Na and Cl. So we have Na and Cl. And this isn't not a hard one because you already know what Na and Cl are. You know that they bond to form sodium chloride, which is salt. But let's just follow our steps. So we're going to identify the charge of each element. This charge is called its oxidation number. So an oxidation number, my face is really close to the screen, is the charge or associated charge of an element. Okay, so what's our charge that we just learned, that Na, from Na? If we look back at that other table, it shows us that Na is in the first column, so it's going to have a +1 charge. So Na has a charge of +1. Okay, and Cl is going to have a charge of -1 since it's in the final column, column 17. Step 2 says to write them in ion form. That is what this means. So this is Na plus 1 and Cl minus 1. And the total charges must equal 0. So does plus 1 and minus 1 equal 0? Yes. So what's going to happen is they're just going to swap charges. So the one goes here and the one goes here, which results in us just having NaCl, one copy of Na and one copy of Cl. Let's try another example with beryllium and iodine, or iodine. Yeah, iodine. So beryllium is Be, and iodine is I. So find those on the periodic table and find their associated charges. You can see that Be has a charge of +2, and iodine has a charge of -1. Okay? One way you can think about this is in little boxes. Okay, so Be has a charge of +2 boxes, and iodine has a charge of -1. Okay, these boxes are going to cancel here because these are going to cancel out each other. Okay, so those are going to cancel, leaving us with one extra positive. So this doesn't associate with rule number 3 that our charges must equal 0. So what we're going to have to do is add an extra -1 so that our charges equal to 0. How we're going to do this is we're going to have 2 copies of iodine. So see how I added one box? Beryllium comes with 2 already. 2 come in one pair, whereas iodine comes in separate sets of 1 and 2. So we have to have 2 copies of iodine so that our answer would be BeI2, because we have 2 copies of iodine to equal out the 1 copy of beryllium. Another easy way to do this is you just swap the numbers. So the 2 goes to the iodine, the 1 goes to the beryllium to give us again Be1, I2. And of course we can ignore that 1 because the 1 is implied to give us Be, I2. You have some other ones to practice on your worksheet. So go ahead and pause the video really quick and practice those on your own, please. Alrighty, hopefully you practice those. So the first one is Mg and Br, magnesium and bromine. So again, hopefully you found that the answer here was we had a +2 on magnesium and a -1 on bromine, so that we're going to get MgBr2 as our answer. Cesium and oxygen, again, is going to be very similar. We have cesium with a +1 charge and oxygen with a -2 charge. Okay, these are going to associate. We're going to swap our charges to get CS2O. Notice how every single one of these has a positive and a negative charge, because our goal again is to always get to that charge of 0. Na and S is going to form Na2S. And to check the other ones, you should get Kf with no associated charges and AlP, aluminum phosphide. Okay. You do have some practice worksheets on those identifying different oxidation numbers, so please let me know if you have any questions on this, but your major thing is going to be to remember that little tiny chart we went over at the beginning. Okay, this is going to be very helpful to you. It's going to be super important that you know all of these have a +1 charge. Okay, let me grab my marker out. All of these have a +2 charge. Why isn't my marker working? All of these have a +3, plus or -4, and if that's ever the case, we'll see what happens there, but remember those are generally going to share. -3, -2, -1. Okay, so we go 1, 2, 3, 4, 3, 2, 1. We're forgetting about the valence electrons of 7, so this is not going to be a +7 charge, it's only a -1 charge. Okay, that's something you're going to have to remember. If it helps you, make sure you write it down on your periodic table. Let me know if you have any questions. Thanks.